Hello, hello, my dear friends. Anyone is in live? Hi, Yashwant. Hi, Vaishnavi. Hi, hi, Guru Sai Charan. Good evening, Vaishnavi. Good evening. Good evening, Yashwant. Good evening, Sai Vaishnavi. Still, anyone is in live? Good evening, Shubhankar. Good evening. May I know who is this Ajit Boxer? Good evening, Shubhankar. Good evening. May I know who is this Ajit Boxer? Good evening, Jasmine. Good evening, Joshita. Shubhankar, hi. Okay, fine. I said you hi. Now, still anyone is in live? Manish. Good evening, Manish. May I know who is this Manish? Good evening, Akshay. Good evening. Good evening, Sai Kirtan. Good evening. Harika. Okay, I'm Harika. Okay, fine. Now, my dear friends, now we know the mole concept. Hi, Akshay. Hi. Mole concept is the calculation part. My dear friends, now I just want to give you the one suggestion that actually for each question I will give you 2 minutes. My dear friends, actually this is a calculation part. Don't use any calculator, because in your exam they will not allow you any calculator. I just approx answer also you can give, but don't use the calculator. Now in the exam they will not give you the any calculator. Now if you know the concept also, if you don't know the mathematical calculation, now it will be difficulty for you. Clear? In the mole concept, the calculation, how much fast you do the calculation, that much fast you will get the answer. Okay, don't use the calculator. If you know the answer, just give me say me the answer. If not, just you give me the question mark. I am ready to explain, because in the less time we have to cover the n number of questions. Now we'll start the. Acha. Hi Alekia. Now in the less time we have to cover the n number of questions, so be fast. Hello Sonu, good evening Suraj. Now we'll move with the first question. Now see the question, and Semida is asking the empirical formula. Now what is the empirical formula of this question? Good evening Arjuna, good evening. Now what is the empirical formula for this question? Now try to say me the answer for this one. What is the answer? Hi Akshay, hi. I said you hi. My dear friend, I was saying you hi. Good evening Nawaz, good evening. Hi Akshay, hi. My dear friend, now what is the answer? Good evening everyone. Akshay, hi, okay. My dear friends, if you keep on, my dear Akshay, if that repeatedly, if that hi comes, I will just block you from the live session. What is the answer? What is the answer you got, my dear friends? What is the answer you got? ABC3. Oh, option number 3 is also there. Sorry, this is, let's suppose. Okay, option 2 and option 4 are same. Good evening, Lasya. Good evening. No, let's take option 4 is a, no, option 4 is correct. Yes, option 4 is correct. Yes, option 4 is correct. How the option 4 is correct? Now we'll see. Here what he has said, A is having the 32% of the weight. B is having the 20% of the weight. Then what is the percentage of the C? Then the C as not given means this is 32 and this is 20. Total it is become 52. Now to complete the 100%, the remaining percentage left is 48. So this is a 48. Now divided by the molecular atomic masses. Now what is the atomic masses of the A? Divided by the 64. Now this if you divide it by the 40 and this if you divide it by the 32, then what you will get? How much you will get? How much you will get? Here 32 by 64 you will get the 0.5. 20 by 40 you will get the 0.5. Then 48 by 32 you will get approx 1.5. Then the least moles we have to divide it by the entire, right? Then 0.5, 0.5 and 0.5, right? Approx what you will get? You will get the 1. Now this one you will get the 1. Now 1.5, 0.5 approx it will give you the 3. So this is a A1, B1, C3. A1, B1, C3, it is present in the option number 4. Option number 4. Clear? Option number 4. Right. My dear friends, is the video and audio is clear, everyone? Is the video and the audio is clear, everyone? Can anyone say me the video and the audio is clear? Is the video and the audio is clear? Now we'll go to the next question. Now we'll move to the next question. So what is the answer for this question? Yes. Okay. Now what is the answer for the next question? In which case the number of molecules of the water is maximum. Number of the molecules of the water is maximum. Maximum number of water of the molecule is asking. Yes, tomorrow's exam it will be useful. Shaikh Nawaz is saying the option number 1. Now my dear friends, you have to solve all the options and say me. Don't give me simply. Don't give me the simply answer. You have to, why not? Now how many moles that in the option number 3 it has came? How many moles that option number 3 has came? And how many moles that option number 2 has came? How many moles that already moles they have given? Then in the option number 2 and option number 3 and the option number 1, in the option number 1 how many moles it has came? Now you have to say. Option number 1 is correct only, but in the option number 1 how many moles it has came? How many moles it has came? Then here my dear friend, here this he has not given the STP condition. Then how you guys are saying it as option number 1 and how many moles that option number 1 has came? How many moles that option number 1 has came? Here whenever the 18 ml of the water if they are given, density they will not give you in the question. So the density of H2O you have to consider it as a 1 gram per ml. 1 gram per ml. Then here 18 ml you have given, right? 18 ml. 18 ml means 1 gram per ml, and weight of H2O that present in 18 ml will give you the what? 18 ml it will give ml it get cancel. 18 if you send it to the left hand side, 18 gram. So 18 gram is nothing but 1 mole. Means 18 ml is nothing but 1 mole. This is a 1 mole of H2O. You have to be very careful with this one. So 1 mole of H2O contain Avogadro number of molecules. This is 0.18 by 18. It will give you something less than 1 mole. Then here the 0.00224 liter by 22.4 liter also if you do, that also it will get less than 1 mole. 0.3 mole. So 1 mole contain Avogadro number. Then 10 to the power 3 contain 6.023 into 10 to the power how much? 10 to the power 20 molecules. But 1 mole contain 10 to the power 23 molecules. So only in the 1. My dear friends, you have to be very careful with this one. Very careful with this one, because 18 ml of water contain 1 mole. 18 ml of water, 18 ml of water contain 18 gram of H2O, that it will give the 1 mole. 1 mole contain Avogadro number of molecules. So the answer is 1. So the answer is 1. Right? Now, next one. 1 mole of nitrogen gas is the volume of. 1 mole of nitrogen gas is the volume of. 1 mole of nitrogen gas is the volume of. 1 mole of nitrogen gas is the volume of. Option number C. Option number C. Good, 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 everyone, good. Good, 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 everyone, good. See, 1 mole he has given, 1 mole. Option number C. So, 1 mole of N2 occupies 22.4 liter of 22.4 liter of N2 at STP. At STP. Yes. Okay. Option number 3. Option number 3. Then, if suppose, next. Okay. Good, 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 good. Option number C. Next. Find the volume of CO2 obtained at STP on eating 200 grams of 50% pure CaCO3. Don't take it as a 50%. Okay. You say me just 50%. Now, what is the answer you got? %50 pure. Harika is saying option number B. Option number A. See, my dear friends, whenever the pure in the question, if suppose in the question pure CaCO3 is given, if pure CaCO3 is given, now in the 200 grams 50% is only pure. 50% if it is pure means only how much? Only the 100 gram of CaCO3 has been reacted. Only how much percentage if it is pure, that much only it will be react. Then the final volume of CO2 at STP is asking, right? Now CaCO3 upon heating, it will give you the CaO plus CO2 gas. CaO plus CO2 gas. Now CaO, how much molecular weight? 100, right? Now 100, here also we got the 100. 100 by 100, how much you will get? It will get the 1 mole. So 100 by 100 you will get it as a 1 mole, because I got the in the 200 gram only 100 gram of the CaCO3 is only the pure. In the 100 gram if it is pure, then if I find the number of moles of it, one calcium carbonate molecular weight is 100 and it will get the 1 mole. According to this stoichiometry equation, 1 mole of calcium carbonate, it is giving the 1 mole of CO2. Then 1 mole of CO2 will occupy how much? 1 mole of CO2, number of moles is equal to volume occupied into 22.4 liter. Then how much I got? 1 mole. 1 mole if it is sended, then it will go equal. 1 mole will occupy how much volume? 22.4 liter of the volume it will be occupied. Then 1 mole of calcium carbonate if it is eating, 1 mole of CO2 is coming. Now we got the 1 mole, right? 1 mole of the calcium, it will give you the 1 mole of CO2. 1 mole of CO2 contain 22.4 liter. 22.4 liter, right? Now, if suppose if I change same question, if I change with a 80% of pure CuCO3. Can anyone say me how much volume it will be occupied? Instead of what? Instead of giving the 50%, I was given the 80%. How much volume it will be occupied? Now you have to say me. How much volume it will be occupied? You have to say me. How much volume it will be occupied? You have to say me. If it is a 80% pure, how much volume? $35.84. It is giving 38.84. Yes, yes. Good, good. Good, good. Who is this? Akshara has given the answer, and next one Subhana has given the answer. Now, see, 80% pure, right? My dear friends, same you write, same reaction you write. CaCO3 gives rise to CaO plus CO2 gas, right? Now, in the 200 grams, now 80 gram is pure. 80% is pure. If it is 80%, if it is pure means, then here the 2 zeros and here the 2 zeros, it will be eliminated. You will get the 160 gram of calcium carbonate is pure. Only the pure calcium carbonate only it will be reacted. Then 160 gram of calcium carbonate, how many moles it will be presented? 1.6 moles it will present. According to this one mole of calcium carbonate is giving 1 mole of CO2. Then 1.6 mole of calcium carbonate will give you how many? Just if you cross multiply, it will give 1.6 into 1.6 moles of CO2. Then 1.6 into 22.4 liter, if you multiply, you will get the 35.84 you will get. So how much percentage they have given, based on that one you just calculate. I hope it is clear. I hope it is clear for everyone. Based on the percentage they have given in the question, now you just calculate in a 7. Right. Now this is a one tricky question. Actually this is a Mg. This is Mg. Right. Okay. Now say me the answer. Now what is the answer for this question? What is the answer for this question? What is the answer for this question? Answer is D. Once again you cross check, my dear. Once again you cross check. Once again you cross check. Once again you cross check. Answer is C. Someone is saying C, someone is saying C, someone is saying D. What is the answer? My dear friend, don't search in any Google or anywhere. Try to do it by your end, and don't use the calculator. Don't use the calculator. Someone is saying C, someone is saying. Now the answer is A. Answer is A. My dear friend, without knowing the balanced equation, we cannot solve this question. Without knowing the balanced equation, we cannot solve. See what he has given. Magnesium is reacting. Magnesium required to produce 220 ml of hydrogen gas at STP with the excess of dilute HCl. Excess of dilute HCl means HCl, this gives rise to MgCl2 plus H2, means this is 2 moles, right? Here excess of HCl if they have given means this is a excess reagent. This is excess reagent. Then this one will be the LR. This is a limiting reagent. This is a limiting reagent. Now with the help of limiting reagent, we have to the mass of the magnesium required we have to calculate. Now you see how to calculate. Now we'll see. Magnesium, when it has reacted with the excess of HCl, that it is giving the magnesium chloride plus H2 gas. Magnesium chloride and the H2 gas. According to this equation, 24 gram of magnesium will provide ml. They have given, right, ml. So you have to convert that liter into ml. 22,400 ml it will be provided. Then according to the question, what they have given, 220 ml of H2 will produce. Then 220 ml will produce how much magnesium? Then cross multiply. X is equal to 24 into 220 by 22240. Now here the 0 get cancelled. How much it will go? Just if you calculate approx, you will get it as a A. A is the answer. I hope it is clear. My dear friends, without knowing the balancing equation, you will not get the one question also. Even though you know the concept, without knowing the without knowing the balancing equation, you will not get the answers. I hope it is clear for everyone. I hope it is clear for everyone. Now I hope is this Clear for everyone? Yes, sir. Clear. Right. Now, we'll move to the next question. Next question. I hope the question is clear, I think so. Question data and everything. Oh, what is the answer? What is the answer for this question? 54.2% they have given. Now try to give me the answer. Read the question carefully and try to say me the answer. What is the answer for this question? C6H12O6. Hey, don't search in Google. If you without doing the calculation, you within the fraction of seconds you will not get. Actually, this will give you the some complicated calculation. It will give you some complicated calculation. It will give you the answer you are getting. It is a what option D and B you are saying. Without doing the calculation, don't give me the answer. He is asking the molecular formula of the compound. Molecular formula of the compound is asking. My dear Soram Sri Ganesh, answer is not the D. Now next Guru Sai Charan, the answer is not the B. My dear friend, the answer is not the B and not the answer is not the D. Answer is not the, my answer is C. Let me cross check. Here the carbon they have given 54.2, hydrogen they have given 9.2 and oxygen they have given 36.6 divided by 12. Now divided by this much, how much it will get? Divided by 1, divided by 16. Then after the dividing, now what you will get? Now moles you will get 4.52, I think so. You will get 9.2, you will get 2.29. After getting the 2.29, just you divide it by 2.29 and 2.29 and 2.29. Right, after dividing the simplest mole ratio, almost you will get 1.97. This approx we can take it as 2. Then after that, this one will give you approx 4.02. This approx we can take it as 4. Then this one will be the 1. Then the empirical formula will be C2H4O1. C2H4O1. Then he is asking the molecular formula. Molecular formula will be calculated on the basis of N into empirical formula. N into empirical formula. How to identify the N? N is equal to molecular weight of compound by empirical formula weight. Molecular formula of the compound weight is 132 they have given. 132 by, now empirical formula weight how much they have given? Empirical formula weight if you calculate, this is 24 plus 28, 28 plus 16, 28 plus 16 approx it will give 44. 132 by 44. 1 132 by 44. 132 by 44, how much you will get? Option C only you are getting. Okay, let me check. 132 by 44, it is giving 3. So C2H4O1 into 3, it will give C3H12O3. Sorry, C6H12O2. So answer is D. Okay, fine. Answer is D. Okay, my dear friends, answer is D. Now the n value I got it as 3 here. Then if you multiply with the empirical formula, answer we are getting D. Good. Answer is D. Right. Next one. The number of moles of methane required to produce 11 gram of CO2 gas after the complete combustion. Combustion reactions, if they have given, we know, right? Now the combustion reaction, now what is asking? The moles of methane required to produce 11 gram of CO2. 11 gram of CO2. For the 11 gram of CO2, how much it required is asking. Now, my dear friends, without knowing the reaction, you will not get the answer. Without knowing the reaction, you will not get the answer. What is the answer you got? Are you trying? My dear friends, are you trying? Sia. Arey, methane combustion reaction, methane means CH4, right? CH4. Now what is asking? After complete combustion means combustion reaction will be happen in oxygen. Now it will give you the combustion reaction, it will give you the CO2 plus H2O. Now what I said? Now I said you one thing. What? First to balance the carbon. In this combustion reaction, first to balance the carbon. How many carbons we are having? 1 carbon. Here how many hydrogens we are having? 4. So if you take it 2, it will become 4. Right? Then he is asking how many moles required for to produce a 11 gram of CO2. Right? According to the balanced equation, 1 mole of methane required 1 mole of CO2. Means here 16 gram of methane required 44 grams of CO2. Then 11 gram of CO2 require how many grams of methane is asking? How many moles is asking, right? 16 gram is nothing but 1 mole. So 1 mole of CH4 required 44 grams. Then 11 gram of CO2 required how many moles of CH4? Just you cross multiply 11 by 44. If you do, you will get the 0.25. 0.25 is the answer. Is it clear? Is it clear? Answer is B. Answer is B. Right? Right. The amount of calcium oxide produced on heating 150 gram of limestone, 75% pure. Okay, my dear friends, for sake of you, instead of kg only, better you take kg only. Kg only. No. It is multi-correct answer. That answer should be in the kg. Okay, for sake of you, what I will do, I will make it in the grams. So it will give you more lengthy calculation. Better I will give you it in the grams. Same is the answer in grams. Now if you check in the Google also, the answers you will not get. If you do only, you will get the answer. Okay. I was given in the 150 gram. Now same is the answer. Instead of kg, I was given the answer. Answer also give me in the gram. Calcium oxide produced on heating 150 gram of limestone. The amount of calcium oxide produced on heating 150 gram of limestone, 75% of the pure is. Are you getting the answer? Are you trying? $37 grams. Okay, let's see. Now CaCO3, upon heating we got the calcium oxide plus CO2 gas. Calcium oxide plus CO2 gas. Then we know 100 gram of calcium oxide is producing 40 plus 16, 56 gram of calcium oxide. Then in the 150, only 75% of the pure limestone has been reacted. Then how much it will get? 3 and it is 2. Then it will give the 75 into 3. 75 into 3 it will give 15 and 1. It will give you the 21, 21, 22. 225. 225 by 225 by 2. 225 by 2, how much it will get? This is 11 and this is 12.5. So 112.5 gram will give you how much? Now if you cross multiply, x is equal to 56 into 112.5 gram of calcium carbonate divided by 100. Now if you do, you will get the answer. That how much you will get? 56 into 112.5 by 100. You will get 63, right? How come you got the 42 and 37? My dear friends, the answer is 63 grams. What is asking? The amount of calcium oxide. The amount of calcium oxide produced on heating 150 gram of limestone 75% pure. Now in the 150, 75% will be 105. Yeah? Sorry. Let me check. In 150, 75 percentage, right? 75 percentage by 100. The 150, 75 by 100. 11.2 only. Yes. Then 11.2 will give you almost 63 gram. I hope it is clear. I hope it is clear for everyone. Correct only, right. Now x is equal to 56 into 112.112 112.5 by 100, that it will give 63. Is it clear? Right, 63. Right, done. Next one. Which of the following contain largest number of atoms? Which of the following contain largest number of atoms? Which of the following contain largest number of atoms? Which of the following contain largest number of atoms? Yes. 75% pure they have given. 75% pure. Means in the 150 gram only 75% of the pure limestone only it has been reacted. So you have to consider only 75% of the pure. In the 150, 75 pure only reacted. Now someone is giving 4, someone is giving Soram Sri Ganesh is giving answer 4. Vaishnavi is giving 1. Guru Sai Charan is giving 1. My dear friends, don't be in hurry to give the answer. Cross check the each and every option. Cross check the each and every option. Is asking largest number of atoms. Don't see the largest number of atoms by in this one. Just cross check and say me the answer. See, 11 gram of 44 into 3 into Na. Okay. Now this one will be the 4 by 2 into Na. Now this one will give you 5 into 17 into 3 into Na. Now this one will give you 8 by 32 plus 32, 64 into 3 into Na. Right, 3 into Na. Here it will give you the 2, right? 2 into 2 it will give you the 4 Na. Here how much it will give? 33 by 44 it will give you less than 4 Na. It will give you less than 4 Na only. 33 by 44 it will give you approximately, it will get less than 1 mole. It will get less than 1 mole. Then here it will give you the 15 by 17 Na. 15 by 17 also it will get less than 1 mole. Then here this will be give you how much? 24 by 64. This will also will give you less than 1 mole. So all are giving the less than 1 mole. All are giving less than 1 mole. So here in the hydrogen only we got the 4 moles, right? So the option 2 is correct, right? Don't be hurried by seeing the, don't see the molecules and don't see the atoms and give the answer. Cross check the number of moles. The one which is having the higher number of moles will have the higher number of molecules. The one which is having the higher number of moles. The answer is B. Each and every answer you have to cross check and you have to say me the answer. Each and every option you have to cross check and you have to say me the answer. Okay. Now, next one. Calculate the number of atoms in 52 gram of He. 52 gram of He. Calculate the number of atoms in 52 gram of He. 52 gram of He. What is the answer you got? Answer is A. Good, good, good. Who has said the answer first? Arjuna has said the answer. Lasya has said the answer. Subhana has said the answer. Now Rishita has said the answer. Bindu, Suraj. The answer is A. 52 gram of helium is asking, right? Number of atoms formula. Number of atoms formula we are having number of moles into Na into atomicity, right? Number of moles 52 by 4 into 6.023 into 10 to the power 23. Atomicity of helium is 1, right? This was how much it will give? 4, this is 2, and this is 6, and this was it will give 1 and 3. 13 into 6.023 into 10 to the power 23, it will give you option A. Answer is option A. 13 into 6.023 into 10 to the power 23, if you calculate, you will get option A. Answer is option A. You have to be very careful with this one, option A. 1 mole of magnesium burn in air forms magnesium oxide. The mass of the oxygen used. Say me the answer. The mass of the oxygen used. Answer is A. A na. Answer is C. See, magnesium is giving the magnesium oxide, MgO. This is a magnesium oxide. Then 1 mole of magnesium required half mole of O2. See, 1 mole of magnesium required half mole of O2. 1 mole of magnesium required half mole of O2. Then what is asking? 1 mole of oxygen contain 32 gram of oxygen. 1 mole of oxygen contain 32 gram of oxygen. Then half mole contain how much? 16 gram of oxygen. So 1 mole required 1 mole of required, this is how much, Amma? This is how much, if you cross check it from here also, you'll get 24 plus 16, right? 24 plus 16. 1 mole required, half mole of O2. 1 mole contains 32 gram of O2, half mole contains 16 gram of O2. So answer is A. Answer is A. Good, good. Everyone, my dear friends, who has given the answer, good. Now I hope this question is clear. A compound contains 4% of hydrogen, and he has given the chlorine. Molecular weight also given, is asking the molecular formula. Hydrogen weight they have given 4.071%. Carbon weight they have given 24.27%. Chlorine weight they have given 71.65%. Now what is asking? Molecular formula is asking. Molecular formula is asking. Options not given, just you have to say me the molecular formula. My dear friends, I can speak Telugu, I can speak Kannada, I can speak Hindi, but I can teach the class in English and Telugu, but in other two languages it is very difficult for me. What is the answer you got, my dear friends? What is the answer you got? So that's the reason I will teach it in max. I will teach it in English only. I will not use any Telugu. I will not use any Telugu, my dear friend. Don't worry. I will teach it in English itself. But in Hindi, the teaching it will be very difficult for me. Sure. I will speak in English only. C2 Cl2H4. C2Cl2CH4. Now we'll see. Here, now the percentage of the carbon they have given it as a 4, and chlorine they have given just, now you can see. Now the carbon weight they have given 24.27. Hydrogen weight they have given 4.027. Chlorine weight they have given 71.65. So total it has become how much? Total it has become 100%. Then divided by 12, its atomic weight. Divided by 1, its atomic weight. Divided by 35.5. Then if we divide it by 24.27 by 12, if it is giving approx, it is giving 2.022. Now it is giving 4.07. Now 71.65 by 35.5, it is giving approx 2.01. Then if you divide 2.01 and 2.01, it will give you C1H2Cl1. C1H2Cl1 you got. Then after that he has given the molecular weight. N is equal to molecular weight 98.96 he has given. Then if you calculate its empirical formula of molecular weight, it is 12, it is 2, 14. 14 plus 35.5. 14 plus 35.5, how much it will give? 14 plus 35.5, it will give you 49.5. 49.5 approx in value you will get it as 2. Then molecular formula will be equal to 2 into empirical formula, right? 2 into empirical formula. This empirical formula we got it as a C2H4Cl2. Good. C2H4Cl2. That empirical formula we got C1H2Cl1. Now we got the C1H2Cl. Then it will get the C2H4Cl2. Right? C2H4Cl2. I hope it is clear. Here the carbon weights they have given, divide it by its molecular weight. Divide it by molecular weight, you will get the moles. The one which is the least mole, that least mole divided by the entire moles. There you will get the empirical formula. After getting the empirical formula, molecular weight they have given in the question. To get the n value, you have to divide it by the molecular weight of the compound given in the question and this empirical formula weight. This empirical formula molecular weight. This empirical molecular formula weight 49.5. If you divide it, you will get it as a 2. Then molecular formula is equal to 2 into empirical formula. 2 into empirical formula will give C2H4Cl2. That's it. Next question. 10 gram of calcium carbonate was treated with excess HCl. The volume of CO2 gas evolved at STP. Now, say me the answer. The volume of CO2 gas at STP. The volume of CO2 gas at STP. The volume of CO2 gas at STP. Answer is D. My dear friends, once you cross check and see me the answer, don't give the answer simply. Equation if I was given, then what the use ama? No, here without equation only. Equation if I was given, then equation if I was given, how come do equation CaCO3 upon heating, it will give CaO plus CO2 gas. Chal, this is a balanced equation. Now say me the answer. This is a balanced equation. Now this is a balanced equation. Now you can say. What is the answer you got? Yeah. I will be end by the 840 or 830. More questions are there. See, 100 gram 1 mole will occupy 22.4 liter of the gas at STP. Then 10 gram will give you how much? Cross multiply. That's it. X is equal to 22.4 into 10 by 100. It will give you 10 approx it will give you 2.24 liter. So answer is A. Answer is A. Yes, yes. Now I will write the one question. Now based on this question you have to give me the answer. Now I will write the question here. Now you have to give me the answer. So what is the question he has given? What the question he has given? The question: hemoglobin contain 0.33 percentage of iron by mass. The molecular weight of hemoglobin is approx 67200. The number of iron atom, Fe atomic weight is 56. Fe atomic weight is 56. Present in one molecule. Can anyone say me the answer? What is the answer? My dear friend, this is very, very important question, and based on this concept you may get a question. Direct or based on this concept you may get a question. Tomorrow's your exam, based on this concept or direct question of this one, you will get the answer. So what is the answer? Don't know, sir. Now listen, I will explain. Here what it is saying, 0.035 gram, right? Now 0.33 gram of iron that present in 100 gram of hemoglobin. Then 67200 gram of hemoglobin contain how much iron? This is iron by weight that present in 100 gram. Percentage they have given, right? That is percentage by. Then 6700 contain how much? Just you cross multiply. X is equal to 0.33 into 67200 grams by 100. Right? This will give you approximately, it will give you the weight 221.76 gram of Fe it will get. Then you got the weight, right? Weight. After getting the weight, just you find the number of moles. One iron only it is there, right? Now what? 221.76 by 56 if you do, you will get the number of atoms you will get. That's it. What is the answer? That is 4. That's it. Answer is 4. Answer is 4. I hope it is clear. Answer is 4. Answer is 4. I hope it is clear. Yes, answer is 4. Yes, good. Rohini, good, Rohini. Good. I hope it is clear for everyone. Now we'll move to the next question. Next question. An oxide of sulfur, an oxide of sulfur contains, an oxide of sulfur contains 50% of sulfur. 50% of sulfur. What is its empirical formula? What is its empirical formula? A SO, B SO2, C SO3, D S2O3. D S2O3. Now see me the answer. What is the answer you will get? What is the answer you will get? What is the answer you will get? B. Yes, good, good, good. Good. Guru Sai Charan, good. See, an oxide contain 50 sulfur, 50% by weight. The remaining will be the 50% will be the oxygen. Then sulfur weight will be 32. This one will be the 16. This one will be the 16. Then 32 by 50 by 32 how much? 50 by 32. This is 1.56. Now 50 by 16. It will give you 3.125. Just if you divide it by 1.56 and if you divide it by 1.56, it will give you approximately 2. It will give you 1. So this is S1O2. So answer is B. Answer is B. S1 and the O2. I hope it is clear. I hope it is clear for everyone. I hope it is clear for everyone. Just another question. Another question I will give you. The chloride. Yes. The chloride of a metal. The chloride of a metal contains. The chloride of a metal contains 71% chlorine. 71% of chlorine by weight. By weight. And the vapor density of it is 50. Of it is 50. The atomic mass of the metal. The atomic mass of the metal. Atomic mass of the metal will be. Atomic mass of the metal will be. Now say me the answer. A 29. Sorry. Atomic mass of the metal will be A 35.5, B 29, C 71, D 58. Now say me the answer. A chloride of a metal contain 71% of the chlorine by weight and the vapor density of the compound is 50. Vapor density of the compound is 50 and the atomic mass of the metal will be. 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 Answer is D. Sai Vaishnavi is giving C. My dear friends, the same question I was explained today in the morning in the class also. Same data question. For the main students, I was explained the same question in the class also today. Dia. Now you see here what I was given. Now the what is saying the question, a 71% of the chlorine by the weight, vapor density of the compound is 50. So vapor density formula will be molecular weight by 2. If it is 50 into 2, if you do, you will get the molecular weight of the compound. Molecular weight of the compound you will get. Molecular weight of the compound. Molecular weight of the compound is 100 grams. Right? In this 100 gram, 71% of the chlorine is there by the weight. 71% of the chlorine by the weight means 100 into 71 by 100 means 100 get cancel, you will get the 71 gram is chlorine. 71 gram is chlorine you are getting. So he is asking the metal, atomic weight or molecular weight of the compound. Molecular weight of the compound will be what? Atomic weight of metal plus atomic weight of chlorine. Now in the 100 gram atomic weight of the chlorine we got it as a 71. Then molecular weight of the compound we got it as a 100. So what you will get? 100 equal to atomic weight of metal and atomic weight of the chlorine we got it as a 71. Got it as a 71. If you send it to the left hand side, atomic weight of the metal will get it as a 29. Atomic weight of the metal will get it as a 29. Right? Atomic weight of the metal will be the 29. Answer is option number B. Option number B is correct. 29 is the answer. Not 58, my dear friends. You have to cross check. Without simply you should not say the answer. Each and every option you have to cross check and you have to say me the answer. Simply if you say the answer, you will not get the questions. Okay? I hope it is clear for everyone. Next one. The next question we are going to see. Yes. Clear. Now, next question. A sample contain, I hope the question is clear. A sample contain 0.6.02 into 10 to the power 20 molecules of CO2. Calculate the number of molecules in the sample. Calculate the number of moles in the sample. Rohini, you are in the class 9th. Okay, you can listen to the class so that it will be practice for you, and advance you can listen to the class of your class 11th. Okay, you can try. How many questions you can try. My dear Rohini, how many questions you are getting, that many questions you can try it by your end. What happened? A sample contain 0. A sample 1 mole you take, refer to the 1 mole. Just 1 mole contain 6.022 into 10 to the power 23 molecules. He has given 6.02 into 10 to the power 20 molecules contain how many moles? That's it, simple. X is equal to 6.02 into 10 to the power 20 by 6.02 into 10 to the power 23. 6.02, 6.023 get cancelled. It will give you the 10 to the power minus 3 moles. 10 to the power minus 3 moles it will give. 10 to the power minus 3 moles it will give. Good, good. Rohini, good, 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 good. It will give you the 10 to the power minus 3 moles. I hope it is clear. Next one. Which of the following contain 1 mole of atom? Which of the following contain 1 mole of atom? Which of the following contain 1 mole of atom? Which of the following contain 1 mole of atom? Which of the following contain 1 mole of atoms? Which of the following contain 1 mole of atoms? See here 1 mole of atom means 1 mole of helium contain Avogadro number of atoms, means 1 mole of helium contain 1 into Avogadro number. 0.5 mole of O2 contain 2 into Avogadro number of atoms. 1 mole contain 2 into Avogadro. 0.5 mole will contain 2 into 0.5. 2 into 0.5. Next, 0.5 mole contain 0.5 mole contain 0.5 mole contain now 1 mole of helium atom. 0.5 mole contain atoms is asking, right? 0.5 into 2 into Na. Here 0.5 into 1 also it will give you 0.5 into 2. How much it will get? .5 into 2 is you also get the 1A. 1 mole contain 1 mole of atoms. 1 mole of atom. 1 mole contain Avogadro number of atoms, right? 0.5 mole of O2 also contain Avogadro number of atoms. 1 mole of He also contain Avogadro number of atoms. So answer is A and B. Answer is A and B. A and B both you will get. Which of the following contain 1 mole of atoms? 1 mole contain Avogadro number of atoms. 0.5 mole of O2 also contain Avogadro number of atoms. 1 mole of He also contain 1 mole of atoms. So 2. Next one. This is very, very important. The percentage of nitrogen in ammonia. 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 Each and every answer you have to cross check. Simply you should not give the answer. Now the percentage of nitrogen in ammonia is. Percentage of nitrogen in ammonia is. Percentage of nitrogen in ammonia is. 82 percentage. A. Answer is A. Now, see, percentage formula, percentage of any atom or element, if you want to calculate that, it will give you percentage of nitrogen in ammonia. The percentage formula we have calculate on the basis of atomic weight of nitrogen by total molecular weight into 100. Total molecular weight into 100. Atomic weight of nitrogen is how much? 14. Total molecular weight is 17. Into 100, if you do, you will get the 82 percentage. 82 percentage is the answer. My dear friend, 82 percentage is the answer. Percentage of nitrogen is asking. Only nitrogen is asking. Percentage of nitrogen only is asking. Percentage of nitrogen, atomic weight of nitrogen by total molecular weight, 17 into 100. Right? I hope it is clear. I hope it is clear. I hope it is clear for everyone. Right. Next one. This is also one interesting. 2 moles of Al reacts with Fe2O3. How many moles of Fe are formed? This is a balanced equation. This is a balanced equation. 2 moles of Al is react with Fe2O3. How many moles of Fe are formed? This is a balanced equation. Now you have to say me. Four moles. Rohini has given the answer. It has a 4 moles. Yes. No. See, according to the balanced equation, 2 mole of Al is reacting with 2 mole of Fe. Then 2 mole of Al reacts with Fe2O3. How many moles of Fe is formed? Then you can balance here. 2 mole of Al, according to the balanced equation, 2 moles of Al is reacting with the 2 mole. Then 2 moles of Al in the question he has given. 2 mole of Al. 2 mole of Al will give you how many? 2 into 2, 4 by 2. 4 by 2. So answer is 2. 2 moles. Answer is 2 moles. Good, Subhana. Good. Answer is 2 moles. See, according to the balanced equation, 2 moles of Al is giving 2 moles of Fe according to the balanced equation. Then he is asking 2 moles of Al. Then the 2 moles of Al require how many moles of Fe? 2 into 2, 4, 4 by 2. 4 by 2, it will give 2 moles. Answer is 2 moles, not 4 moles. Answer is 2 moles, not 4 moles. Here already the 2 moles we are having. You have to take the reference. You have to take the reference. How many moles of Fe is formed? 2 moles of Fe is only formed. Directly in the question itself they have given the answer. This is one very interesting and a tricky question. 11 gram of propane measured under the same condition. What volume of O2 measured at 0 degree and 1 atm? Now which condition this is? Is this ideal gas condition or it is ideal gas condition or STP condition? This is ideal gas condition, ORR, STP condition. This is ideal gas condition or STP condition. Now you have to send me the answer. What is the answer you will get? What is the answer? My dear friend, 0 degrees 1 atm is STP condition, not ideal gas condition. It is STP condition. 0 degrees 1 atm is a STP condition. 0 degrees and the 1 atm is a STP condition, my dear friends. You have to be very careful. Answer is B. What volume of oxygen O2 measured at 0 degrees and 1 atm is need to burn the 11 gram of propane gas measured under the same condition? First you write the combustion reaction. Combustion reaction of the propane. Propane formula C3H8 in the presence of O2. It gives rise to CO2 gas plus H2O. CO3 gas and H2O. Now here how many carbons we are having? 3 carbons we are having. Balance the carbon 3. And here how many hydrogens we are having? 8. So balance it with the 4. Right, here how many oxygens we are having? Total 6, 10. Just you keep the 5. Right? Now then here is asking the 11 gram. Just you calculate its molecular weight. 3 into 12 plus 8. 3 into 12 how much it will give? 48. 24, 36. 36 plus 8. How much it will give? 44. So 44 gram of propane required 5 into 32 gram of oxygen. Then volume is asking a volume. So volume if is asking means 1 mole. 1 mole contain 44 gram. 44 gram of propane occupies 5 into 22.4 liter of volume. Then 11 gram will occupy how much volume of O2. Then just cross multiply. X is equal to 5 into 22.4 into 11 by 44. Just it will give you 2. This it will give 2. This it will give 4. Sorry, not 2. 11 and it will go on by 4. This will go by the 2. This will go by 11.2. 11.2. This will go by 5.6. 5.6 into 5. 3. 25, 28. Something calculation it has gone. Now just you cross check. 11 grams will give you how much? 5 into 22.4 into 11 by 44, it will give 28. Volume of O2 gas measured at 0 degree 1 atm 8 to 1. Same condition they have given. If suppose the same condition with the STP, I hope I was taking the propane molecular weight wrong or what. 12 into 3 plus 8, 44, correct only. 5 into volume is asking, right? 28. 28 you are getting. 28, the option is not there, 28. Okay, maybe somewhat mistake it has happened in the questions, I think so. Okay, 28 we are getting, 28 liter we are getting. Okay, once we'll check with the ideal gas equation also. PV is equal to nRT. Volume is asking. Pressure V is equal to N44. Weight they are given 11. 11 by 44 into 0.0821 into 273. Just once you cross check it by this one. 0.0821 into 273 into 11 by 44. It is getting 5.6 liter of the gas. 5.6 is there, approx 5 liter. Now with the ideal gas we got the same condition, right? So if you are not getting, for the given option, if you are not getting the STP condition volume means, then you have to go with the ideal gas equation. Now 0 degrees 1 atm, 0 degrees 1 atm, PV is equal to nRT. This will give you the 0.0821. Approx you are getting 5.6 liter you are getting. Then the nearest option for the 5.6 is, you can take it as 6. Sorry, 5.6 liters for the nearest option, you can take it as 6 liter. You can take it as a 6 liter and you can solve. You can take the 6 liters and you can solve. It is giving 28 by the STP condition, but it is STP condition 28, it is not there. So the 28, the STP condition, it is not there. Eleven gram is 28. What 28, Amma? 1 mole of 44 grams. 44 grams will having the 22.4. 11 grams will give you how much? Correct only. Okay. Now I will write the one question. Now one question I will write you. Just you give me the answer. What is the question I was giving? Now in the Haber's process, N2 plus 3H2 gives rise to 2NH3. This is the ammonia gas. So how many moles of hydrogen molecule required to produce 20 moles of ammonia? So question is, how many moles of H2 required to produce okay, one second, to produce 20 moles of NH3. This is 6. Oh, sorry. Actually, I was taking the 5. Okay. 3O2 I was to take. Correct. Sorry. 3O2. Barabar. I was taking this one. Sorry, 3O2 I have to take. 3 into 22.4 liter. Then if you cross check, 44, once you cross check, 3 into, yes. Here the 6, right? Here I was to keep the 3. I taken the 5. Sorry. I did not cross check. So 11 by 44, 2.5 into 0.25 into 3 into 22.4. 60 now. What is the answer? This is the answer. 44 grams, 11 into 3 into 22.4 by 44, it is giving 16.8. Here oxygen we are having the 6. Here also 6 done. So 44 gram 44 gram is giving 3 into 22.4 liter of the volume. Sorry, okay, we'll cross check with this one. 3 moles of O2 will occupy 3 into 22.4 liter only. Okay, my dear friends, we can take it as a 6 liter according to this ideal gas equation. According to the ideal gas equation, we got the 5.6. 5.6 approx, we can take it as a 6 liter. We can take it as a 6 liter. You can take it as 6 liter. Yes, I got it. 3 next, say me the answer for this one. In the Haber's process, how many moles of H2 required to produce the 20 moles of NH3? This is a balanced equation and is asking how many moles of H2 is required to produce the 20 moles of NH3. Can anyone say me the answer? Thirty. Now we'll see. 3 moles of H2 producing 2 moles of NH3. Then 20 moles will produce how many? 20 into 3 by 2. 10. That will give 30 moles. Right, good. 30 moles of H2 is required. 30 moles of H2 is required. Yes. My dear friends, now up to here I will stop the lecture. Now I hope you have solved the n number of questions. Now it will be more enough for you for your tomorrow's exam. It is more enough. But tomorrow while you are solving the chemistry questions, be very fast, because here I did not see you that whether you are doing the calculation by your own or by your or any math with your phone or calculator, but in the exam they will not allow you any calculator. So try to, even though you know the concept, without knowing the calculation you will not get the answer. So try to be strengthened in the calculation part. Okay, if you know the concept also, if you don't know the calculation, what it will happen? You will not get the answer. So don't cheat yourself. Whenever you are solving any question, try to solve it by your own math. In the mole concept, only the calculation part will play very crucial role. Okay, I was ending the lecture here. If you are having any concern, you can ask. If not, I will end the lecture here. Anyone having any concern? They can ask. If not, I will end the lecture here. If not, I will end the lecture here. Okay. My dear friend, every Friday the question practice session will be there. Every Friday question practice session will be there for the first year, as well as 9:42 and 11:10, like that. Second year session will be there. So every day, every Friday the question session will be there, and in the week the concept will be there. That concept lecture will be tomorrow. I mean, the lecture will be run like mole concept, after the mole concept redox reaction, and after every Friday we are having the question session. Concept will be run at the 7 o'clock the class will start, and the 8:30, 1.5 hour the lecture will run. After the 1.5 hour, once in that week, whatever the lecture we have studied, that lecture's question session will be on the Friday, and it will continue. Good night everyone. Good night my dear friends. Now all the best for the tomorrow's exam. Okay Rohini, every week, my dear, every week you are having the lecture from the 7 to 8:30, and every Friday question session also same times, 7 to 8:30. Okay, Guru Sai Charan, my dear friend. Bye. Good night everyone. Good night. Bye.